fine. Okay, so just wait a second. Let me fetch the question.
कर सकते।
Okay, so wait a second. $7.3. Yeah. So you have been given the total pressure of the system at a certain temperature, and total pressure of 10 to the power 5 Pascal. Iodine vapor contains 40% by volume of I molecules. That means iodine molecules, and the rest of them, they will be I2 molecules. Is that clear with you? Yes or no? First of all, tell me that. So we have I2 gas, okay, and here we have 2 moles of iodine gas. Now what they are saying that there is a total pressure of 10 to the power 5 Pascal, and the iodine vapor contains 40% of volume, 40% by volume iodine atoms. So this is 40% by volume. Any problem till here?
No, sir.
No problem, right? So this is 40%. Now, if this is 40%, that means it is 40 upon 100 into whatever the pressure is. Whatever the pressure is, that will be into 10 to the power 5 Pascal. This will be the total pressure. This will be the pressure applied by these iodine molecules. And by I2 it will be, if this is 40, this will be 60. So this is 60%. This will be 60 upon 100 into 10 to the power 5 Pascal. Any problem till here?
No, sir.
No problem, right? Now they are asking what is the Kp. So Kp is equal to the concentration of iodine, the pressure of iodine whole square, because this is 2 here, and the pressure of I2 molecule raised to the power 1. So the pressure of iodine is how much? 0.4 into 10 to the power 5 whole square divided by, this will be 0.6 into 10 to the power 5. Here, this will be Pascal square, because here we have square and there will be Pascal here. So you will get the Kp in terms of Pascal. So you will be getting 0.4 square divided by 0.6 into 10 to the power 5 to the 10 divided by 10 to the power 5. So this will give you 0.4 square divided by 0.6 into 10 to the power 5 Pascal. So you can just solve this and you will get the answer. Okay, so the idea was this was the only barrier. Other things I think you know, Hana?
Yes, sir.
Okay. So in the last lecture, we ended up with the application of equilibrium constant, and we did the first application, that is the predicting the extent of reaction. Okay, predicting the extent of reaction. Now the second application is predicting the direction of reaction. How are we going to predict that? So let us say we are again starting with a simple reaction, that is A is in equilibrium with B. Okay, A is in equilibrium with B. The equilibrium constant for this case, it is equal to 1. Now I hope you understand what does 1 mean. 1 means that we have the concentration of product divided by the concentration of the reactant. So for each mole of reactant, there will be 1 mole of product. There will be 1 mole of product. Now let us suppose initially I have 20 moles of B and 10 moles of A. 20 moles of B and 10 moles of A. So now you guys have to tell me the reaction can only go like in the two direction. So where it will be moving towards the backward direction or towards the forward direction? Tell me. Look at the initial concentrations. And after a very long time, what should happen? For each mole of A, there should be 1 mole of B. Enough. For each mole of A, there should be 1 mole of B. So now you tell me initially, now when we are taking 20 moles of B and 10 moles of A, so in this case, for each mole of A, how many moles of B is present? Tell me, guys. Look at the numbers and tell me for each mole of A, we have 10 moles of A and we have 20 moles of B. For each mole of A, how many moles of B is there?
20.
For each mole, each.
Sir, 2 moles.
2 moles, na? Yes or no?
Yes, sir.
All of you agree, yes or no?
Yes, sir.
Yes, sir.
Okay. Now what do we need? For each mole of A, we have now 2 moles of B. 2 moles of B. And what do we need? We need for each mole of A, there should be 1 mole of B. Correct? Yes or no?
Yes, sir.
Now the reaction, there will be reaction, and either it will be forward or it will be backward. There is only 2 cases. Yes or no? The reaction can go forward or it can go backward, or it can like just stay in equilibrium. So obviously I can say, is this the state of equilibrium? Are we in equilibrium state? No, no, because at equilibrium, what is going to happen? For each mole of A, there will be 1 mole of B. So please tell me, is this the equilibrium? Yes or no? Is this the equilibrium state? Yes or
No,
no?
sir.
No. All of you agree? Yes or no? Razan, Minashi, Mazia, Memuna, I need answers now. I need answers,
Yes,
please.
sir.
This is not, no? This is not equilibrium state. So if it is not equilibrium, then change will happen, yes or no?
Yes, sir.
Yes, sir.
Change will happen. So there can be one of the reaction, one of the dominant reaction, either the reaction will go forward or it will go backward. Correct? You have only 2 options. Yes or no? We have only 2 options, right? Either the reaction will move forward or it will move backward. Or do you guys think it can only move forward? What do you guys think? Now again, I'm asking, is this equilibrium? Again, I'm asking, is this equilibrium state right now? 20 moles of B and 10 moles of A?
No, sir.
No. So there will be change.
Yes, sir.
Yes.
Now, what are the options? What change can happen? Either the number of moles of A will increase. That means we are going backward direction, or we will have number of moles of B will increase. One of them should increase, the other should be decreasing, right? So there will be a change. It can either be forward or backward. We don't know right now. We want to learn, right? Maybe you have the answer ki sir backward hoga ya forward hoga. I know that kya hoga. But right now I can only say we have only 2 options. In that we have to analyze this condition of 20 moles of B and 10 moles of A. And by analyzing this condition, then I will comment whether it will be forward or the backward change. And reaction kis taraf jayega, whether it will move forward or backward. So right now we have for 1 mole of A, there are 2 moles of B, but I need this ratio. For each mole of A, there should be 1 mole of B. So what do we need to do? We need to increase the number of A, yes or no? And decrease
Yes,
the
sir.
number of B. Yes or no, guys?
Yes, sir.
Yes, sir.
Okay. Now you look at this reaction and tell me, this is the forward reaction, this is the backward reaction, and forward reaction or backward reaction, which satisfy this criteria that A should be increasing and B should be decreasing. The number of A should be increasing, number of B should be decreasing. Please pay attention, guys. इसको ऐसे मत रखिएगा जो लोग नहीं सुन रहे हैं, ठीक है? This is the main part, and this will help you solve all at least 20 questions in equilibrium. This small concept. So tell me, guys, whether this will be forward or backward.
Backward.
Sir, back.
Backward. All of you agree? Yes or no?
Yes, sir.
Yes, sir.
ऐसे ही सवाल रहेंगे बस आपके पास कि आपको दिया जाएगा कि 20 moles, like what is the initial condition, and then you will be asked to predict the direction of the reaction, whether it will be moving forward or backward. Now, right now we have taken a simplest case of equilibrium. K is equal to 1 mole. There is one reactant, one product. Very simple. Like it's a simple और कुछ हो नहीं सकता. Now from this simple case, we will generalize something, and that will be helpful. And we will generalize something that will be helpful for finding the direction of reaction of any reaction, any complex reaction also. So what I will do, so here we have 20 moles and 10 moles. And here we have concentration of product upon reactant. So we know that this K is a special case of Q. So basically, at any condition, at any point of the system, we can define Q as the concentration of product by the concentration of reactant, concentration of product and concentration of reactant. Now, at this point of time, it is not equilibrium, so we will be defining Q. And when we write the Q, we see that there is 20 upon 10, which is equal to 2. And now I compare Q is what greater than K. Now, when Q was greater than K, then I said the reaction is going to be backward. We have achieved this answer earlier. Now we just framed a generalized situation that whenever the Q is greater than K, we will get a backward reaction. Is this fine with everyone? Yes or no?
Yes.
Right. So simply put, we will have three conditions: predicting the direction of reaction. तो मेरा ना पता नहीं कभी ठीक नहीं होगा लगता है. Predicting the rate mean direction of reaction. Predicting the direction of reaction. Now, the first condition can be if the Q that is given to you, it is smaller than K. If it is smaller than K, then what will happen? Forward reaction will take place. Secondly, if whatever Q, that means the initial conditions that you have been given, if the Q is greater than K, then backward reaction will happen. Now, third point, if Q is equal to K, this will be only if you have the equilibrium state. Okay, so we have equilibrium is achieved. When you will have equilibrium, there will be no change. There will be no change. Okay, there will be no change. Okay, so write this question. Done writing the question, yes or no? Please tell me. Yes, guys, done. Okay, let me know if you are done writing the question.
One
Not
second.
done. Acha. So see, so in this question, you have been given a few information, and please remember, whenever you have been given concentration, it does not mean that it is the concentration at equilibrium. Okay, so they will mention you very explicitly if it is the concentration at equilibrium. So right now, if you see this question, they are saying that a mixture of H2, N2, and NH3, that means hydrogen, nitrogen, and ammonia, with molar concentration, they have given 5 into 10 to the minus 3, 4 into 10 to the minus 3, and 2 into 10 to the minus 3 moles per liter respectively was prepared and heated. Was prepared, that means we have taken it, that means it is initial concentration. That means it is initial concentration and heated to 500 Kelvin. The value they are given for this reaction at this temperature is 60 for this reaction. Now they are asking, now you have to predict. So again, in this question, you just have to calculate the Q of the reaction. So Q will be what? What is the product? NH3. The concentration of NH3 whole square, because here we have 2, divided by the concentration of H2 cube into the concentration of N2 into the concentration of N2 that is given to us. So this is the Q because they are giving us the initial concentration. So here we will be having, okay, so NH3 is how much? 2 into 10 to the power minus 3 whole square. This is mole. Okay, let me just write molar. Molar square divided by H2. H2 is 5 into 10 to the power minus 3 whole cube, and this will be M cube into, we have 4 into 10 to the power minus 3. This will be just M. So obviously this M and this will get cancelled. This will get M square. So M to the power minus 2. This will be the unit for the Q here. This will be the unit for the Q here, right? I hope you are not missing anything. Okay, fine. Now here we have 2 square into 10 to the power minus 6. Here we have 5 3s are 15 and 15 3s are 5, sorry, 5 5s are 25. 25 5s are 125 into 10 to the power minus 9 into 4 into 10 to the power minus 3. So first of all, I think these two will get cancelled and you will have 1 upon 125 into 10 to the power minus 6 into 10 to the power 9 plus 3. And these two will be getting added, 9 plus 3. So now you just have to calculate 1 upon 125 into 10 to the power minus 6 into 10 to the power 9 plus 3, 12. So this will be 10 to the power plus 6, right? Yes or no, guys? This will be the Q. Tell me. This will be the Q, now. Any doubt till here?
Yes. No, sir.
So just now you have to, you can compare what is the Q. Q is 10 to the power 6 upon 125. And what is the K? This is the Q. And what is the K that we have? K is 60. So which is greater, Q or K? Which is greater?
Q.
So what will happen if Q is greater? Just you have to look here. Q is greater than, then backward reaction will occur. And what will be formed? Predict whether ammonia tends to form or to decompose, and hence ammonia will decompose. Please write this down. Let me know if you're done. Write this down. Let me know if you're done. Okay.
Done.
All of you are done. Okay. Okay. Now we are moving to a more important point, that is calculation of the equilibrium concentration of reactants and products. Okay. Before that, let me see if we can do a few more questions. Okay. Now let us write the question. Write the topic. The third application is calculation of equilibrium concentrations. Now this is going to be most important. Okay. So the third application, the first application is important. The next application, that is the extent of reaction, is important. Then we have direction of reaction, that is more important. And this is the most important. This is most important application. Now we know that we have to calculate the concentration. So my first question will be, why are we calculating? Why are we not? So whenever we have to identify a value, now, for example, if I have to identify any physical quantity, I have to measure. I can do two things. I can either measure it, or what I can do, I can calculate it. Okay. So please have this framework in your head. Whenever you're talking about numbers, so that number must have been measured somewhere, or it must have been calculated. So whenever you are measuring something, you need a device, and you don't need any other information. You need a device. Okay. You need a device, or you can say instrument. Okay. Now, whenever you have to calculate something, so for calculation, you need some smaller data. Or I say that you need some cheap data. And this cheap data is going to give you a more expensive data or more dense data. Okay. Or more dense calculation or some measurements. So for example, I will give you a very small example. What do you think about volume? Is volume calculated or is it measured? Volume. वॉल्यूम में ना आप चले जाइए 10th स्टैंडर्ड में, you have a chapter in your maths na, mensuration. So what do you think, volume is what, measured or calculated? Tell me, volume is measured or calculated? ये भी नहीं पता.
Measured.
Measured. What is the instrument that measures volume?
So it's calculated.
It's calculated. What about length or breadth or width?
Measured.
Measured. What is the device that we use or the instrument that we use to measure it?
Scale, ruler.
Ruler, inch, tape, है ना? So now whenever
sir.
you see something na that can be measured or calculated, तो ये दिमाग में रखिए, like what can we do? Can we measure this or can we calculate this? So you will always see that whenever you are going to calculate na, so you need some cheap data. For example, volume के लिए क्या चाहिए? Volume के लिए we need some length, some data on distance, and we also need a formula. है कि नहीं? Yes or no? Tell me. No one will say you anything if you ask what is the formula for volume of a cube. लेकिन कोई आपसे अगर पूछ दे कि लेंथ का फॉर्मूला बता दो, so it's very absurd. Now why are you asking me the formula for length when we have a very cheap device that can measure the length? So I will never calculate length. What I will do, I will measure the length. So similarly, concentration. What is concentration? Concentration is number of moles divided by volume. So what is number of moles? Number of moles is the given mass by molar mass. What is volume? Volume is just length into breadth into height. So I think we have devices which can measure weight, and molecular mass is what? Molecular mass is going to be a constant term that I can just look on the periodic table and I will get the molecular mass. And what about volume? I will just take a ruler, I will measure the length, breadth, and height of the container, and I will get the volume. So why are we calculating equilibrium concentration when we can easily measure it? We have these two things, which is number of moles, which can be measured because it is dependent on only one term, that is mass. So mass to measure करने के लिए मेरे पास होता है ना चीज. We have measuring, we have balances, right? And we have electronic devices also that will measure something. Then we have volume. So volume also can be measured by relatively, like we have this formula L into B into H, and that from there we can measure the volume. No matter what container you are taking a cylinder, you have a formula for cylinder. We have a formula for cylinder also. We can measure it. So why are we calculating it? Why are we calculating it? Okay. Now, the question is that why are we calculating it? It is because we have some reaction A plus B in equilibrium with C plus D. In equilibrium with C plus D. Now, initially, if I measure the amount of A, measure the amount of B, that is going to be very easy because initially I'm taking some amounts of A. So I will go to the balance, है ना, जो भी मेरे पास, what do we call that? Weighing machine. Weighing machine. I will go to the weighing machine. I will scoop some A and then pour some A, and we will drop that A, and then we will measure. Okay, fine. This is this much number of, this much grams of A is present. I will divide by molar mass. Then I will just get the number of moles. Then I will divide by the volume of the container. I will get the concentration. Not much of a big deal. Not much of a big deal. But what happens at equilibrium, that after a very long time, these type of reactions which are reversible and they have equilibrium. So at equilibrium in my container, I have A, B, C, and D. Yes or no? All of these are present. Tell me yes or no. Correct?
Yes.
Now अब हमको क्या करना पड़ेगा? Now I will have to separate this A. Then I will have to separate this D, separate this C, and separate this B. Okay. Now what? Okay, fine. We can separate it. But I will tell you about separation. जिन लोगों ने भी चाय बनाई है आज तक, है ना, those who have prepared tea or they have seen someone prepare tea and pouring it, so we have a filter. Right? So right now, let us say that I want to filter all the A, and let us suppose that A is tea only. But what do you think, guys? When we filter it, some of the tea, it is wasted, yes or no? It cannot be filtered out completely. 100% filtration हो सकता है tea का? Tell me yes or no?
No.
No. So the actual amount of A that was present, we will never be able to measure it, because we can't filter it and we can't separate it so perfectly. And one more thing, okay, fine, maybe एक बार कर भी लिया हम. For once, what we did, we separated the A and we measured the concentration of A for once, because we got very sophisticated device. Then we separated the A, B, C, D, and then we calculated the concentration of all the products and all the reactants at equilibrium. So that fancy thing can be done only once, because we don't want to put that much investment on each time we do some reaction, because sometimes reaction can go bad. So we will have to repeat it. Then we will again do the same separations. It is very time consuming. That is why we need a formula to make life easy. We need a formula, we need a way in order to calculate the concentration of the reactant and products at equilibrium. So now I hope all of you understand why are we calculating it, yes or no, and why are we not measuring it. Bataiye. Is this clear with everyone?
Yes, sir. Yes, sir.
Yes, sir.
Now, how to measure it? I will start with a simple reaction, है ना? हम लोग हमेशा ये करते हैं. We will start with something very simple, then we will add to it some complexities. So I have A, which is giving me B. I have A, which is giving me B. Now, we will talk realistically, है ना? ऐसा नहीं करेंगे कि friction zero है physics के जैसा. We will keep things real. So I can't even imagine who is doing a kind of reaction in which they are pouring some A also and they're also pouring some B in the container, and then they are reacting क्योंकि दोनों को लेके चलते हैं हम साथ में. We don't do that. We generally take the reactant molecule and then we start the reaction, है ना? So we will also take in similar way. We will start with what? Initially, we will start with we will start with 10 moles of A, है ना? 10 molar Pascal bar APM, don't know what, 10. Let us just take this number 10 moles of 10 moles of A. Let us take 10 moles of A. So initially we have only 10 moles of A. So initially there will be 0 moles of B. Correct? Yes or no? Yes or no, guys? Tell me. Any dikkat?
Yes, sir.
No problem here till right? No problem till here. Then what will happen? Some of the A will react. Now let us also take that. क्या हुआ एक बार once they did all the separation, they separated A perfectly, they separated B perfectly, and they got the concentration of A and B at equilibrium, and then they put that on the equilibrium constant expression, and they found that K was equal to 1. So for all the reaction that is present and all the common reaction that is present, routine reactions that is present, we have the equilibrium constant for all of those reactions. So for this reaction, the equilibrium constant was, let us suppose, 1. Now, obviously, you can see what is going to happen. A will be converted to B, yes or no? Forward reaction hoga yahan pe, in this case. I hope you can see that. Forward reaction is going to happen.
Yes.
Yes, right. Forward reaction is going to happen because we have more moles of A. We want both of them to be equal. Right now, I know that you can exactly tell me how many moles of A will be converted to B. Yes or no? I think you can see and tell. है ना? दोनों को equal करना है तो 5 moles करना है. Then that means 5 moles of A will react. 5 moles of A will convert itself to B, and then we will have 5 moles of A and 5 moles of B. That will satisfy the equation that is K is equal to 1. But we will generalize it and we will say that since A is reacting, that means the change will be minus X. Yes or no? Change will be minus X. बताइए yes or no? Please tell me. Can I take minus X as the change? बोल ही नहीं रहा है, नहीं आ रहा है क्या आपको ये समझ में? Can you say no, sir, at least? Minashi,
Yes, sir.
can you please respond? ऐसे आप लोग क्यों शांत बैठ जाते हैं? बोल दीजिए एक बार कि सर फिर से समझा दीजिए. Turn your mic, all of you. Please turn your mic. ऐसे नहीं चलेगा ना, because you are not writing. I want response. Tell me. Turn the mic on, all of you. Please turn the mic on, guys. Abdul Rahman, Khalil, Maimuna, Minashi, Razan, Mahreen, Sayyid Muhammad, and Yusra. All of you turn the mic on. Tell me. What is the initial concentration of A? What is the initial
10.
concentration of
10.
A?
10.
What is the initial concentration of B?
0.
0.
What is the equilibrium constant for this reaction?
1.
1. So, for each mole of A, how many moles of B do we need?
1.
For each mole of A, how many moles of B do we need?
1.
1. One.
बाकी का नहीं आ रहा जवाब, बाकी को नहीं आया ये समझ में, है ना? टाइम बिताइए, पढ़ाई चालू कीजिए जिन लोग जो लोग जवाब नहीं दे रहे हैं, ठीक है? फॉर ईच मोल ऑफ ए आई नीड 1 मोल ऑफ बी. सो टेल मी, in this case the reaction will be forward reaction or backward reaction when we have 10 moles of A?
Forward.
Which
Yeah.
reaction will be taking place?
Forward.
Forward reaction. That means A, the amount of A will be decreasing or increasing?
Decreasing.
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 So I can take minus x, yes or no?
Yes. Yes. Yes.
Yes.
Now the amount of B will be increasing or decreasing?
Increasing.
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 Now you tell me, if 1 mole of A reacted, then how many moles of B will be formed?
1.
I hope you can see from the stoichiometry. Agar A to B, this is the reaction that is happening. So if I have 1 mole of A, then 1 mole of A will give me 2 moles of A. Sorry, 1 mole of A is going to give me 1 mole of B. If I react 2 moles of A, it will give me 2 moles of B, yes or no?
Yes, sir.
Yes, sir.
So now B is increasing, so there will be plus X, yes or no?
Yes.
Yes, sir.
Then we have equilibrium. At equilibrium, what will happen? We had initially 10 minus X, and here we'll be having just the X. This is the concentration of A at equilibrium. This is the concentration of B at equilibrium. And after that, we will write the K, that is equal to the concentration of B upon the concentration of A. And this will be equal to how much? This will be equal to 1 because the equilibrium constant is 1. Now what I'm going to do, I'm going to write the B concentration. What is the concentration of B? It is X. What is the concentration of A at equilibrium? It is 10 minus X, which is equal to 1. And hence I will say X is equal to 10 minus X. So 2X is equal to 10 and X is equal to 5. That means at equilibrium, we will have 10 minus 5, 5 moles of A and 5 moles of B. So this is the simplest thing that you can have. Now I am asking if I had A and B. So mainly you can see that you have table. The table is important, A and B. Now initial is how much? Let us say 10 and initial for B was 0. So the change was, what was the change? The change was minus X and this was plus X, yes or no?
Yes, sir.
All of you agree, yes or no?
Yes, sir.
Okay.
Yes, sir.
Now if I have some reaction in which we have A, which is giving 2B, and initially it was, the initial was 10 and the B was 0. B was 0. The change will be minus X and the change at B. So for each mole of A, we are getting 2 moles of B. So I can write this will be plus 2X. Is this clear with everyone? Yes or no?
Yes, sir.
Yes, sir.
What about others? All of you understand this, not 2X?
Yes,
Yes,
sir.
sir.
Okay. Similarly, if I had A plus 2B in equilibrium with 3C, then I will write, let us say 10, 10, and there is 0 initially. So the change will be X minus of X because we have 1 mole of A. Minus of X, for B it will be minus of 2X, and for C it will be plus of 3X. Is this clear with everyone?
Yes, sir.
Yes,
है
sir.
ना? Is this-
Yes, sir.
Okay. Now we can do questions. यही आना है आपको. This is what I call as ice table. है ना? We have ice table, initial, change, and equilibrium. Initial, change, and equilibrium. And what is equilibrium? Equilibrium is initial minus change. Initial minus change is the equilibrium. So just wait a second. Let me pull up the question. Write this question, please. Okay, please let me know if you're done writing the question.
Done, sir.
Okay, now see this framework that I have made now: initial, change, and equilibrium. Okay, so this, you just remember this framework, and we will try to do all the questions according to this framework. So in most of the questions, initial will be given, and it is also logical that the initial concentration or the initial pressure should be given, because when I am doing some reaction, then I will know now how many moles of A and how many moles of B I have taken. Okay, so a good question they will give you. I say, like there are many questions in NCERT and in 11th and 12th standard that they want to familiarize you with very many different things. So like what a foolish question it would be if they give you the equilibrium concentration, जो कि tough है निकालना, and they are asking you the initial concentration. Okay, so if you see that type of question, you just think that, oh my god, क्या ही बेवकूफ सवाल किया है. Okay, maybe that question is tough, but that question is nonsense question because it is not solving a problem. A problem is what? Problem is the equilibrium concentration, because it is difficult to separate them and it is difficult to measure them. और कोई आदमी अगर equilibrium concentration ही देखी initial concentration पूछ रहा है, that means he is a fool. Okay, so a good question will always have initial that is given to you. Is this clear? Yes or no? Makes sense to all of you? The initial should be given. Yes or no?
Yes, sir.
Yeah. So if you have if you pick up any competitive exam questions, they will always give you initial. Okay. Then next is the change. The change you have seen, that change के लिए हमको कुछ नहीं देखना था. In the change here, when we were talking about the change, did we look at the initial concentration? No, no. We looked at the reaction. Yes or no? We looked at the chemical equation that was given to us and that determined the change. Yes or no? Tell me.
Yes, sir.
Yes, sir.
Okay. So always, how will you write the change? For the change, you will look, you have to keep your focus. You have to keep your focus. Change, you will look at the chemical equation. यहाँ वहाँ नहीं देखना है ना. You have not to go here and there. The chemical equation will give you the change. The chemical equation is going to give you the change. Now, equilibrium. For equilibrium, we have initial minus change, that is a variable, है ना? Because change is a variable we are taking as x. So this initial minus change, it is a variable, and we are going to solve this by relating the equilibrium concentration or pressure by the Kc or the Kp that is given, or there will be something which will be given about the equilibrium. Something will be given. Something in the question, it will be always given about the equilibrium. I'm not saying Kc or Kp. They may give any other thing, but they will say at equilibrium, this is something. This is something at equilibrium, this is happening. So then we have to relate whatever is given about the equilibrium to the initial minus change, to the initial minus change. Is this clear with everyone? Will this framework, please remember this framework and let us apply this framework in the question here. Now you tell me, is the initial given, yes or no?
Yes, sir.
Given?
Yes, sir.
एकदम साफ साफ given है कि नहीं? Please tell me. Initial is given. So let me just write the reaction first of all. We have this reaction carbon monoxide plus H2O, which is in equilibrium with carbon dioxide plus H2, plus H2. So tell me, what is the initial? What is the initial, guys? What is the initial mole of carbon monoxide? इतना कोई किसी को बोलना ही नहीं, हम नाम लेके बुलाएं क्या आप लोगों को? यार क्यों इतना टाइम लगाते हो आप लोग? What is the initial concentration of carbon monoxide? अरे अभी तो बोल रहे थे सब कुछ दिया हुआ है. What happened?
0.10.
ये दूसरे लोग क्यों नहीं जवाब दे रहे? रजान, मिनाशी, महरीन, मैमूना, खलील, you did not see? What is the initial concentration? Keep your mic on now. Again, all of you keep your mic on. Turn your mic on, guys. हाँ बताइए. Initial concentration of CO?
0.10.
0.10. Initial concentration of H2O? Keep your mic on. Keep your mics on.
0.1.
Initial concentration of H2O is 0.10. Initial concentration of CO2? Initial concentration of CO2 is how much?
Not given.
Not given? Nahi, given. It is given. Read this. Is
Zero.
only carbon monoxide and H2O are present initially. So what does that mean? Is CO2 present? Yes or no? Is CO2 present initially?
No.
No, na, Khalil?
No, sir.
है ना? Because they are saying ना, if only CO and H2O is present initially, that means और कुछ है ही नहीं. Now, for change, where will you look, guys? Keep your mic on. तो 10 बार keep your mic on ही बोलना पड़ रहा है. Keep your mic on, guys. Don't turn it off until the class. हाँ, just keep it on. Others. Now tell me, what is the change for CO? What will be the change for CO?
Minus
The
X.
amount of CO, the amount of CO will increase or decrease?
Decrease.
Decrease.
What is the stoichiometry here? 1, so it will be minus X. What about H2O? Increase or decrease?
Decrease.
Minus X. Now tell me, for CO2, what will be the change for CO2?
Increase.
Plus X.
Plus X. For H2?
Plus.
Plus X. Plus X.
Okay, then at equilibrium, what is the concentration of CO at equilibrium? Initial minus change, बोलिए ना, initial है, change है, tell me, initial minus change. Initial minus change नहीं, initial and change हो जाएगा यहाँ पे. Like it is, you just have to add them rather. Initial minus change is like not proper, I would say. Tell me, at equilibrium 0.1 minus X, है कि नहीं?
Yes, sir.
What about H2O?
0.1 minus X.
0.10 minus X.
What about carbon dioxide?
Plus.
X, right?
X. Plus X.
X and X. Now, so we have got a equilibrium concentration. So we can write the K, which is equal to the concentration of products, CO2, H2, by CO and H2O. So this will be equal to X into X, 1 minus X, 0.1 minus X. This will be equal to, and what is the K given? K they have given us 4.24. X square divided by 0.1 square minus 0.2x plus X square. So you have a quadratic equation. Please write till here. Solve quadratic equation, yes or no? Yes or no? भूल गए 10 के बाद भूल गए.
Yes, sir.
So you have chemistry till here, है ना? You have got an equation now in which you have to find x. So from here it is maths. Okay, from here it is going to be maths. Then guys, yes or no? लिख लिया तो प्लीज बोलिए. नहीं लिखा है अभी तक. Are you guys calculating x? Yes or no?
Yes.
Are you guys calculating
Yes,
x?
sir.
हाँ, you guys have just 3 minutes. Okay, 3 मिनट के अंदर आपने किया तो ठीक है, otherwise it will be homework. I think I've got an answer. Let me see. No, Minashi, I don't think that is the right answer for x. Did you approximate a lot, Minashi?
Sir?
Did you approximate many things?
No.
So you have done with this quadratic formula, x is equal to minus b plus minus under root b square minus 4ac upon 2a.
No.
तो कैसे किया फिर आपने?
I took denominator into numerator.
क्या 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 क्या? Explain. Minashi, what did you do?
4.24 into 0.1 square minus.
Wait a second. 4.24 into
Into a bracket 0.1 whole square minus 0.2x plus x square.
this is equal
Equal
to
to x square.
x square. And after that?
Then x square will cancel.
Wow. Wow, very good. No. Yes, Khalil, you're right. No, Sayyid Muhammad, no, I don't think that is right. Yes, Razan is correct. Sayyid Muhammad, आप ये देखिए ना, आपने लिखा है +4. Initial concentration 0.1 है. So So it cannot be like the change cannot be more than the initial concentration, है ना? So you also check that. Okay, yes, Khalil and Razan, you are right. You can't, you cancel it like this. So ऐसे cancel कर दिया आपने, विनाश जी?
No, sir, before taking to numerator, I cancel. Like,
वो पहले ही cancel कर दिया आपने यहाँ से.
yes.
पाप है ये, पाप है. अरे ये कबीरा गुनाह है मैथ्स में. Oh my God. अच्छा. So like, so ऐसे 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 भी करते थे क्या आप?
No, sir.
तो फिर ओहो, मीनाक्षी, you have maths or you don't have maths? नहीं होना चाहिए आपके पास maths. नहीं है ना आपके पास maths?
No, I don't have.
हाँ, very good, very good. अगर होता तो हम छुड़वा देते. If you have had maths, I would have called your school and बोलते कि इसको छुड़वा दीजिए, maths पर पढ़ाइए इनको. मैमूना. Turn the mic on, Memuna.
Yes, sir.
You are saying that x is the change, right? X to change, है ना? Yes or no?
Yes.
So you are saying it is 0.44, and the initial concentration is 0.1. Is this possible?
No.
है ना? So you will get one more value. You will get one more value, है ना? That will be the right one, which will be less than 0.1. Okay, because you have
yes,
plus
sir.
minus. Okay, so Minashi, I think I need to tell you first of all, ये तो ऐसे तो होगा नहीं, तो बहुत पीछे हैं, कैसे किया जाए आपके पास? What will be the answer, Minashi? No, Mazia, ये Mazia तो minus में आ जा रहा है. No, that's not right. Minashi, 10
Yes,
plus 2
sir.
divided by 2. What will be the answer?
6.
क्यों? 10 होना चाहिए ना?
No. 12 by 2.
You did the
6.
same thing, ना? नहीं, like you cancelled the x in the same way, ना? Yes or no?
Yes, sir.
X square,
Yes.
है ना? So there is a operation. First of all, you have to like simplify these numerators, है ना? Simplify whatever is in the numerator and denominator. Then only you can cancel things. And addition method, you can never cancel in addition. You can, but what about this case? This will be how much?
10.
10. यहाँ पे cancellation हो सकता है, right? Because multiplication and division, they are same thing only. एक दूसरे के inverse है बस. Okay. So you will need a quadratic, you will get a quadratic equation, and in which you will apply the quadratic formula where x is equal to minus of b plus minus under root of b square minus 4ac divided by 2a. You remember this? देखा देखा तो लगना चाहिए,
Yes, sir.
है ना? So you will get a quadratic equation, then you will have to solve it, and the correct answer is 0.067. I think a few of them got. X is equal to 0.067. This will be in molar. So we have these concentration of COH2O. So let me write first. The concentration of CO is equal to the concentration of H2O, which is equal to 0.1 minus 0.1 minus X. This was the equilibrium concentration. So be equal to 0.1 minus 0.067. Then what else do we have? We have the concentration of CO2 and H2. CO2 and H2 at equilibrium, they both are equal to X, and which will be equal to 0.067 molar. So this will be equal to how much? 0.033 now. Okay, so you got the concentration at equilibrium of all the reactants and the product. So this is how K equilibrium is applied in order to get the equilibrium concentration. Is this clear with everyone? Yes or no? Please tell me.
Yes, sir.
Yes, okay. Fine. So let me just get .11 is sample of HI equilibrium, the partial pressure of HI is this much. What is the KP for the Okay, let me share my screen. Yeah, can you see this textbook NCERT?
Yes, sir.
So can someone read the 7.11? Read out loudly, bhai. Read it loudly. I think this question so we did now. This is okay. Sample available place in 0.2 ATM at equilibrium. The first read it. And this is rather easy question to just calculate the KP. We don't have to calculate the equilibrium concentration. I am looking for equilibrium concentration. Okay, wait a second. Ignore that question. This is more towards the easier type of questions. So I'll just give this. Yeah. So we have a pure sample of PCl1. PCl5 was introduced into a vessel, evacuated vessel. That means vacuum at 473 Kelvin. After equilibrium was attained, concentration of PCl5 was found to be 0. Molar. If the value of Kc is this much, what are the concentration of PCl3 and Cl2 at equilibrium? So again, you have initial, something at initial it is given. Pure PCl5 was there, was introduced to evacuated vessel at 473 Kelvin. After equilibrium was attained, concentration of PCl5 is given at equilibrium, and the K is given at equilibrium, and you have to find the concentration of PCl3 and Cl2. So simply we'll first of all write the reaction like this: PCl5 at equilibrium with PCl3 plus Cl2. Okay. Now at initially it is having some moles. Okay, let me just write that it is having A moles of PCl5 is there, 0 moles of PCl3 and Cl2 is present. We don't want to write the, if you want to write the change, you can write the change. This is initial, this is change, and this is at equilibrium. So change is how much? Change is minus x, this will be plus x, and this will be plus x. But at equilibrium, A minus x we will write. But this A minus x, it is given to be how much? Was found to be 0.5 into 10 to the power minus 1 molar. Yes or no? The concentration of PCl5 at equilibrium is given. After equilibrium was attained, concentration of PCl5 was found to be this much. So we don't need A and X. We just kept it like that. Okay, so this is the concentration of PCl5 at equilibrium. What is the concentration of PCl3? It is X. Concentration of Cl2 is also X. Now Kc was given to be, Kc will be equal to concentration of PCl3, into the concentration of Cl2 divided by the concentration of PCl5. So K is given 8.3 into 10 to the power 8.3 into 10 to the power minus 3, which will be equal to x into x upon, here you have how much? 0.5 into 10 to the power minus 1. So you will just multiply them. So x square, it will be equal to 8.3 into 10 to the power minus 3 into 0.5 into 10 to the power minus 1. So you will get, we'll just root it and you will get the x, and that will be the concentration of PCl3 and the concentration of Cl2. Is this question understood by everyone? Yes or no? Please tell me. Is this understood by everyone?
Yes, sir.
Okay. Okay. Let us look at this question. bromine monochloride, BrCl, decomposes into bromine and chlorine and reaches equilibrium, for which the Kc they have given to be 32 at 500 Kelvin. 32 at 500 Kelvin. If initially pure BrCl is present at concentration of this many moles, what is the molar concentration in the mixture at equilibrium? So see, आपको initial दिया हुआ है. Please tell me, is the initial given? Yes or no? Is the initial
Yes.
given? है ना? Initial is given. Then do you have the reaction? Yes or no? Change is given.
Yes,
You
sir.
have the reaction, no? You have the
Yes, sir.
reaction. Okay, now what is given about the equilibrium? There is something given about the equilibrium. What is given about the equilibrium?
So Kc is equal to 32.
Very good, very good. है ना? Kc दिया हुआ आपको. So from equilibrium you have been given Kc. So if something from the equilibrium has been given, and initial and change will also give me one type of equilibrium. We will represent an initial and change, we will represent the same equilibrium. You can do this, yes or no? You get the gist? Are yes or no?
Yes,
Nahin.
sir.
Yes, sir.
What about others? Same. It is like completely same. You have 2 BrCl. So 2 BrCl is going to give me Br2 plus Cl2. Here I will write initial concentration is 3.3 into 10 to the power minus 3, 0, 0. Here I will write minus of 2x because 2 is the stoichiometry. You'll get x and x. Then you have got the equilibrium concentration of these and these two. Then you will just represent them in Kc. You will represent them in Kc and you will get the answer. Okay. Oh, sorry. Sorry guys, sorry. आप लोगों ने तो बताया ही नहीं. ये हम यहाँ पे लिख रहे थे. हमने NCERT का टेक्स्ट बुक वाला बता दिया. Sorry. So initial is given, change is given, equilibrium is Kc, and 2 BrCl is going to give me Br2 plus Cl2, and so this is how you are going to make the ice table, and after that you will just represent them in terms of Kc, and then you will get the answer. Okay. Now next, moving on, let me just give you one more question. So you have many questions like this, but there is one question that requires a bit of calculations, and so let me do that question for you. Yeah, this is the question. No, please don't write it right now. पढ़ते हैं इसको पहले. So see, 13.8 gram of N2O4 was placed at 1 liter reaction vessel, at 400 Kelvin and allowed to attain equilibrium. If the reaction is N2O4 is decomposing into 2NO2. The total pressure at equilibrium was found to be 9.15 bar. Calculate the Kc, Kp, and partial pressure at equilibrium and partial pressures at equilibrium. So we have initial, then we have change and equilibrium. So change is so given, no problem. Okay, what is given? Is the initial given? Is anything about the initial given? What is given about the initial? कुछ दिया है कि नहीं दिया initial का? Mass is given. So from mass you can calculate number of moles. Yes or no?
Yes.
Yes, sir.
And how will you calculate from moles to concentration? That is molarity. What do you need? From moles to molarity, what do you need?
Volume.
Volume is given.
Yes.
Volume is given. That means initial concentration is given. Yes or no? Initial concentration is given. Yes or no?
Yes.
Initial concentration is given. No. Initial concentration is given. Now, moving on. Change to hai because you have the reaction, right? Now, what is given about the equilibrium? What is given about the equilibrium? कुछ भी दिया हुआ equilibrium का?
Total pressure.
हाँ. Total pressure. So framework is working. Now we have to we have to represent. So if total pressure is given, that means I will not be writing this in terms of molarity. What I will be doing, I will be writing in this in terms of, we have number of moles, this is gas, so we can write the pressure. We will represent the K, or we will write the initial and changes in terms of pressure, yes or no? Because we have been given total pressure. अब आपको समझ में आया, like how you have to tweak things, yes or no? Where you have to take KC, where you have to take KP. Yes or no? Tell me.
Yes, sir.
No, because total pressure is given. So, this framework is going to help you very much. So now we have 13.8 grams of N2O4 was placed in 1 liter vessel at Kelvin. These are the things. So let's first of all we want to calculate the pressure. So for that we will first of all calculate the number of moles. Number of moles. So number of moles will be equal to the given mass by molar mass. So the given mass is 13.8 grams divided by the molar mass of N2O4 now. N2 nitrogen and 92. It will be 92, I guess. 92 grams per mole. Okay, 92 grams per mole. So this grams and grams will cancel each other out. You will get 13.8 divided by 92 mole. This is the number of moles. If you have this is the number of moles, then we know that PV is equal to nRT. PV is equal to nRT. So P will be equal to nRT upon V. So V is what? 1 liter, and number of mole is 13.8 divided by 92 into R. What should we take as R? Because we have been given in bar. Like bar mein hai na? So if it is in bar, what do I have to take? 0.0831 or 0.0821? I think we did this in last class now. What R we have to take?
0.0831.
0.0831.
0.0831.
Yeah. 0.0831 followed by liter bar per Kelvin per mole, है ना? So that liter and liter will be getting cancelled because we have here 1 liter. Okay, हम इसी वजह से बस यहाँ पे units लिख लेते हैं. Nothing more. We have got the R, and what is the temperature? 400. So we'll get a pressure, yes or no? We'll get a pressure which is
Yes.
13.8 into, ये इसको ऐसे कर लेते हैं, 8.31 into 4 divided by 92. ये 4 तो कट जाएगा हमको लगता है. 4 how much za? 4 2s and 4 3s, right? So 13.8 into 8.31 divided by 23. I hope I am right. Nothing is wrong till here, right?
Yes, sir.
Nothing is wrong. Okay, fine. So we have got the pressure. We have got the pressure. We have got the pressure. So what do I want to do? Do I want to solve this, or should I leave it like this only? Okay, so what do I need to do after this? I need to write the reaction, and then I want to give the ice, and from ice, yeah, it will be better if I solve it here. Yeah, so हम क्यों करेंगे? आप लोग कीजिएगा इसको. Please tell me what is the value of P. and 8. So maybe I can do 14 and 8. 14 and 8, and there is 23. So the 140, 140, 140, 140, 130, 136, 136, 136, 126, 122. So 122 divided by 23. Yeah, correct. Yusra and Namuna, correct. 4.98 bar. This will be the pressure. 4.98 bar will be the pressure. Okay. So we have got the pressure. Now I am going to write the reaction, that is N2O4. It is in equilibrium with 2 moles of NO2. We have initial, we have change, we have equilibrium. So at initial it is 4.98. This is 0. the change will be minus x and this will be plus 2x. I hope no one has problem with this, the change. That is most important. At equilibrium, we will have 4.98 minus x and this will be plus 2x. Any problem, guys? Yes or no? Please tell me. No problem now?
Okay.
No problem. Okay. Now we know that total pressure is equal to how much? Total pressure is given 9.15 bar, right? 9.15 bar. So total pressure will be the pressure of N2O4 at equilibrium plus the pressure of NO2. So we have those pressures, right? The pressure of N2O4 is how much? So 9.15 bar will be equal to 4.98 minus x plus 2x. So I can write this will be equal to 4.98 plus x 9.15 and this x will be equal to 9.15 minus 4.98, right? Yes or no? So this will be 4.17, I think. So we have equilibrium pressure and the sum of the partial pressures at equilibrium will be equal to the total pressure. This is the relationship that we had to crack up. Hai ki nahi? Now you have got it? Yes or no? Please tell me. Okay.
Yes,
So we have got the change. We have got the change. We have to now we will calculate the Kp. So Kp will be equal to the concentration of NO2 square divided by the concentration of N2O4. So NO2 square is how much? 2x square divided by 4.98 minus x. 4.98 minus x. Okay. So this will be equal to 2 into 4.17 whole square divided by 4.98 minus 4.17. So we'll have to calculate the Kp. You will get the Kp. Now we also know that Kp is equal to Kc into RT to the power delta Ng. RT to the power delta Ng, right? Yes or no? Yes or no, guys? Yeah, so you will get the delta Ng. We have this reaction. So delta Ng is how much? Products minus reactant. So product is 2 moles of gas. Reactant may we have 1 mole of gas, that will be equal to 1. So we can just write Kp is equal to Kc times RT. And rather we need to find the Kc from Kp. No? So we have the Kp. So Kc will be equal to Kp upon RT. But maths, here you have maths. Chemistry to ho gaya. Chemistry was still here only. है ना? These relationships are chemistry. These relationships are easy. Then you have maths, जहाँ पे आपको square करना पड़ेगा. Then you will have to divide something like very, what I can say is very not complex, but rather very tiring maths you have here. So my suggestion will be that whenever you get a question of equilibrium, you test the question, and you will get an idea. If you have this framework in your mind, initial change and equilibrium, what are the steps that you have to do? And what are the steps that you have to do? So after getting the idea of those steps, या तो आप उसको उसी टाइम कीजिए. Otherwise, if you have any more questions left ना, which are easy and that you can easily write, so please do them early. उनको पहले कर लीजिए. Equilibrium question you keep it at last, because these may have 2 marks or 3 marks, but they will consume very like a lot of time. They will consume a lot of time. So my suggestion will be that leave these questions for the later stages of the examination. पहले आसान वाले कर लिया कीजिए. But again, it depends on you how you write the examinations. Okay. Now the next is, let me discuss one more topic. So you will do question number from homework will be 7.8 to 7.14. I think 7.14. I think 7.23 you can do. You can do it till 7.23, I think. 7.23. Even 2.4 you can do after discussing this question. मैमूना को याद आ जाएगा ये सवाल। Okay, so let me first of all discuss the topic relationship between delta G and equilibrium constant K. Delta G and equilibrium constant K, or rather delta G naught and equilibrium constant K. So we have a equation in which delta G of any reaction, that means Gibbs free energy of any reaction, is equal to the standard Gibbs free energy plus RT ln Q, where Q is the reaction quotient. So at equilibrium, two things happen. The Q, it becomes equal to the equilibrium constant K that we have discussed earlier. And at equilibrium, nothing happens. Now, if nothing is happening, that means this change will be zero. Delta G of any reaction, it will be zero. So delta G is going to be zero. Delta G naught is never going to be zero. Why? Because delta G naught is a constant value that has, it is a constant value for a particular reaction, that has been already calculated. So delta G naught is not going to be zero. The delta G of a certain condition that we are giving a reaction, that is going to be zero at equilibrium. So at equilibrium, Q is equal to K, delta G is equal to zero, and hence you'll get zero is equal to delta G naught plus RT ln K. Now I can write that delta G naught is equal to minus of RT ln K, where K is the equilibrium constant. Now there is a relationship between this ln is what? Ln is equal to log of base E. But we have the log tables and we do general calculation in the terms of log of base 10. And the relationship between log E and log of base 10 is that log E is equal to 2.303 into log 10. Okay, so log of A to the base E is equal to 2.303 log of A to the base 10. Now here we can write delta G naught is equal to 2.303. So minus and we'll just put here RT log. Now this is, whenever I write log, it means base 10, ln means base E, log of K. So log of K, for log of K I can write log of K will be equal to the delta G naught and minus 2.303 RT. Now another thing that you have to remember is what is this log. So if I talk about log of 100, it is just a representation. Let me tell you about log. Achha, please answer, okay? 1 plus 2 is equal to 3. Okay, I have this equation. Can you see this? 1 plus 2 is equal to 3. You all can see that now? Yes or no? 1 plus 2 is equal to 3.
Yes, sir.
Okay. So if I ask mathematician kaise sochte hain na, how they start making new things, I will just tell you now how log came into existence. So they said that what is 3? 3 is the sum of 1 and 2. What is 3? What is 3, guys?
Sum of 1 and 2.
Sum of 1 and 2. Okay, what is 2?
Sum of 1 and 1.
Difference of 3 and 1.
1.
Easy equations.
Yeah.
Easy equations. Okay, 3 and 1. Now what is 1? It is the difference of
3 and 2.
3 and
3 and 2.
3 and 2. So they said that if we will have three different numbers of, or let us say that variable है ना, यहाँ पे plus numbers की जगह तो कुछ और आ सकता था. So if we have 3 variables, then there should be 3 operations also. There should be 3 operations, and I should be able to define all of those 3 terms. Then they came up and then they said that 10 square is equal to 100. Okay, what is 100? It is the square of 10. What is 100? What is 100, guys? Square of
10.
Square of 10. And what is 10? It is the root of 100. है कि नहीं?
Yes.
है ना? Root of 100. Now what is 2 in terms of 110? What is 2? Do we have anything that you can think of? I will give you 1 or 2 minutes. You have to represent 2 in terms of 10 and 100.
2 is the exponent. Okay.
नहीं तो कैसे लिखेंगे इसको यहाँ पे हम? 2 तो exponent है, but how will I write this? Like mathematicians, they need some way to represent in terms of numbers and equations. Huh? So think about it. 2 is the exponent. Correct. Very good. Correct. But as we represented 100 in terms of 10 and 2, right? And we also represented नहीं 10 and 2 ना 10 and 2 देखिए we also represented 100 in terms of 2 है कि नहीं? Yes or no? Tell me.
108.
Sorry. 2 to the power minus 1, that means it is equal to 1 by 2. So we are representing by only these numbers 10, 100 and 2. 10, 100 and 2. Tell me what happened. Somebody said something. I could not hear that. Okay, what is 100 by 50? Mazia, I think you understand why 100 by 50 will not work here. Because I want to
Yes, sir.
represent 2 in terms of 10 and 100 only. So I think you don't have any mathematical operation right now that can represent 2 in terms of 10 and 100. Is that correct? Is that correct, guys? Khalil, Maimuna, Mazia, Mirashi, Marine, Razan.
Yes,
Yusra, you're trying to say something. So the mathematician said that we will represent 2. We will represent 2. Otherwise, there will be some gap in mathematics. So they invent things. They will invent things if they will have gaps in rules. So they are not going to change the rules. They will invent new things. So they invented a new function. They said that we will say that log of base 10, log of 100 with base 10 is equal to 2. Okay. So log is nothing. Log is what? If you have log of 100, so there will be a base here. So 10, this will be equal to 2. So this gives you a relationship that 10 square is equal to 100. All of you got it? Yes or no? Please tell me. है ना? तो देखिए आप लोग को आ गया log. अब आप लोग को log आ गया. अब बताइए log of 1000 to the base 10 कितना होगा? 10 to the power how much is equal to 1000?
3.
3. देखिए आ गया log आ गया आप लोगों को, है ना? देखिए see log of base, let us say log of 4 to the base 2 is equal to how much? So 2 to the power how much is equal to 4?
2.
2. है ना? Okay. See, so you have got it. You have got the log. You have got the log. Again, let us say if you have log of 10 is equal to how much? So log of base 10. Log of 10 to the base 10. So 10 to the power how much is equal to 10?
1.
1.
Very good. Now, if you have log of 1 to the base 10, 10 to the power how much is equal to 1?
0.
0. है ना? ठीक है. अब यहाँ पे देखिए, यहाँ पे भी हम लोग को वही करना है. So if I want to calculate the k, then this log is log to the base 10 because we have written log and 2.303. So 10 to the power of this much will be equal to k. Yes or no? Yes or no, guys?
Yes, sir.
Yes, sir.
So I will write k will be equal to 10 to the power of minus delta G naught upon 2.303 RT. Okay. So this is the relationship between delta G naught. This is the relationship between delta G naught and k. Delta G naught and k. So I will just give you a question here. Yeah, can you see this question? Please tell me. Calculate the delta G naught and the equilibrium constant for the formation of NO2 from NO and O2 at 298 Kelvin. Okay, this is the reaction that they are asking to calculate the delta G naught of. Okay, Maimuna, can you see this question? Yes, Maimuna.
Yes.
यही था ना? We had the same question, right, in your examination? Yes, ma'am, Mona? Okay, I can't hear you, Ma'am Mona, now. Also, I want to tell you, Ma'am Mona, see, can you see this F? जो आपके पेपर में प्रिंट नहीं हुआ था,
Yes, sir. Yes.
है ना? Okay. So please write this question, guys. We will do this question and then we will end the class. And so I will not take the class, like अभी 1 hour break के बाद we usually take a class ना. I will not take that class, but you have to do from 7.8 to 7.24. Okay, this is the only reason I'm not going to take the class, that you do these question. Okay, please do this question. तो मेरा like what I have to do, I can complete the syllabus now. If I will take that 1 hour, I will be completing the syllabus earlier only. But it's better to complete things in a strong way and in a more consistent way rather than just keep on going on. So please at least try to do like 10 questions from 7.8 to 7.24. Okay. Then we will meet on Sunday and Saturday and Sunday we have classes. No, yeah, we will meet then on Saturday and Sunday. So did you write the question? Yes or no? Please tell me.
Yes, sir. Yes.
सबने लिख लिया है ना? Okay. So see, whenever you have this, this is a part of thermodynamics also, thermodynamic question also. So you have been given the delta G naught formation of NO2, formation of NO and formation of O2. So obviously O2 is going to be 0. Why? Because it is in the most stable state, right? You remember these things, yes or no? Why O2 will be 0? Why
Yes, sir.
O2 will be 0? Yeah, very good. So you have been given enthalpy of formation. And if you remember, I said that all the enthalpy that is given now, all the enthalpies that is given, that will correspond to a particular reaction. You remember this, yes or no? Because whenever we started enthalpy of formation, we wrote a reaction. Enthalpy of combustion, we wrote a reaction. So whenever you have been given an enthalpy of something, you will write the corresponding reaction. Yes or no, guys? You remember this from thermodynamics?
Yes, sir. Yes, sir.
So what is given here? Enthalpy of formation of NO2, है ना? So I will form NO2. Now tell me, what are the elements that are forming NO2? What are the elements that are forming NO2?
Oxygen and nitrogen.
So what is the most stable state of nitrogen and oxygen? Nitrogen is present in?
And
What is the formula?
N2 plus O2 gives NO2.
N2 plus O2. So I will have to do half O2, है ना? Because half N2. Sorry, I will have to do half N2. Correct?
Yes.
Okay. So I think all of you agree with this. Let me just take this a bit above. Yeah. So this is the first reaction. For first reaction. Wait a second. Wait a second. Let me reshare this thing. Okay. So now you tell me. What about NO? NO is formed from half mole of N2 plus
Half
half
mole of
mole of
oxygen.
O2 gas. Okay. So now you tell me, we have these reactions given, 2 reactions given, and then we have target reaction. याद आ रहा है थोड़ा thermodynamics? We have a target reaction and 2 reactions are given. Okay. So now you tell me NO2. NO2 is in the product or reactant in target reaction. NO2 is in the product or where is it?
Product.
Product. So we'll write this as it is, Anna. We will write this as it is.
Yes.
Yes or no? Okay. Now tell me, what about NO? It is in reactant or product?
Reactant.
Reactant. So we will reverse this. Yes or no?
Yes.
And we will reverse this. So we have the reactions half N2 plus O2 giving me NO2. Then we have NO giving me half N2 plus half O2. So the delta G formation is equal to, the delta G for this reaction is 52 kilojoule per mole. And the delta G for this reaction will be minus 87 kilojoule per mole. Yes or no? We have reversed this, so we will get minus sign. है ना?
Yes, sir.
Now half N2 will be cancelled. Here you have NO plus O2. Here we have one O2. Here we have half O2. So they will also get cancelled, and half O2 will be remaining in the reactant side, and you will be getting NO2 in the product only. Yes or no?
Yes, sir.
Delta G will be, just add these two. So 52 plus minus of 87. You will get the delta G naught. So 7 minus 2 will be 5, and 8 minus 5 will be 3 in negative kilojoule per mole. So please tell me any doubt till here.
No, sir.
No, no. Then we have to calculate the, what they are asking. Calculate the equilibrium constant. Calculate the equilibrium constant. So we know that K is equal to 10 to the power of minus delta G naught divided by 2.303 RT. Yes or no, guys? This is the relationship. Now, the equilibrium constant is equal to. So first of all, what we will do, we will first of all write what is this? Delta G naught is minus of minus 35 kilojoule per mole. So minus 35 into 1000 joules per mole. We have to keep this in joules, not kilojoules, because R will be in terms of joules. 2.303 into what will be R, guys? Kilojoule per mole. In terms of joules, what is R? In terms of joule, what is R? What is the value of R? अच्छा नहीं याद है आप लोगों को. It is 8.314. Okay, 8.314 joules per Kelvin per mole into temperature. What is the temperature given here? Temperature they have given 298. They are given 298. So we'll get this as 35 into 1000 divided by 2.303 into 8.314 into 298. So calculate this. We'll be getting this as 6.13. Are you getting this value? Yeah, guys, tell me. Are you getting this value?
Yes, sir.
No. Okay. So, Mamuna, this is similar to what was given in your question paper also, na?
Yes.
No. So I said now that will be only equilibrium constant. जो आपको anti-log का value दिया हुआ है. So actually, this how we have written na 10 to the power minus this. This is also written as the anti-log of minus delta G naught upon 2.303 RT. So we have seen that this is equal to 10 to the power 6.13. This is the k 6.13. Okay. So ये अभी आप इतना ही कीजिए, k is equal to 10 to the power 6.13. How to calculate this power? How to calculate this power? We can calculate it, but for that, let us reach ionic equilibrium, and then when in ionic equilibrium, we will be learning about the pH. When we will be learning about pH, I will have to tell you about the logs, and we will have a detailed half-hour lesson about logs, and you will be calculating logs. So in that, you will also calculate how to. You will also learn how to calculate the powers of 10 which are in decimal. 10 to the power 6.3. How you will calculate these things? Okay. So as of now, just write this, and so we will meet on now Saturday, but please 7.8 to 7.24. Please complete these questions. And I'm not going to take that